Today we will be discussing about the activity series of metals. So what is the activity series of metals? Now metals are arranged in the decreasing order of their reactivity, and this series is known as the activity series of metals. If you see the table that is seen on the screen, you will see that potassium is right on top and platinum is right down. So potassium is the most reactive metal, whereas platinum is the least reactive metal. So this series in which the metals which are very reactive are placed on top, and as the reactivity decreases, they are placed below. Okay, so this series is known as the activity series of metals. Now, if you look carefully, you will see that hydrogen is also there. Now, we all know hydrogen is a non metal. But why is hydrogen placed in this series? Hydrogen, though a non metal, has been included in this series because it forms a positive ion. Okay, so all metals form positive ions, and hydrogen, though it is a non-metal, it also forms a positive ion, and hence it is placed in this activity series. So let's go into details of this activity series and what information can we derive from this activity series. First one, reaction with oxygen. Potassium and sodium are placed on the top of the activity series of metals because they are the most reactive metals. Potassium and sodium react with oxygen even at normal temperature to form potassium oxide and sodium oxide. If you look at the screen, you will see that K plus O2, the second one, gives out K2O. So K2O is potassium oxide. Similarly, sodium Na plus O2 gives out Na2O, that is sodium oxide. Now, let's see the first reaction. K plus O2 gives out KO2. Now, when potassium and sodium are heated, they will form superoxides. So, KO2 is a superoxide of potassium. Similarly, NaO2 is a superoxide of sodium. So, when potassium and sodium are heated, they will form superoxides, but in normal temperature, they will form oxides. Now let's see how other metals of the metal activity series as we move down react with oxygen. Calcium and magnesium, they do not react with oxygen at normal temperature. We have to heat them, then only they will form calcium oxide and magnesium oxide. Aluminium, however, reacts with oxygen even at normal temperature. Now, below aluminium, we have zinc, iron, lead, copper, mercury, silver, gold, and platinum. Now, zinc, iron, lead, and copper will react with oxygen only when they are heated. Okay, and they have to be heated to a very high temperature. Then silver, gold, and platinum, they do not form oxides even on strong heating. So, from the metal activity series, we come to know that as we move down the metal activity series, the formation of oxides also decreases. Like right on top, potassium and sodium, they formed oxides even at normal temperature. Then, slowly, the metals have to be heated to form oxides. Then, they have to be strongly heated to form metal oxides. And finally, when we come down to silver, gold, and platinum, even when we heat it to very high temperature, also oxides are not formed. So the reaction with oxygen decreases as we go down the metal activity series. Now let's discuss about the reaction of metals with water. We already know that potassium and sodium are right on top of the metal activity series. Potassium and sodium, they react vigorously with cold water to produce hydrogen. And when potassium reacts with water, it burns with a lilac flame, and sodium, when it burns or it reacts with cold water, it burns with a golden yellow flame. Now, these reactions, that means the reaction of potassium and sodium with water, is so vigorous that an explosion may take place. Potassium and sodium are highly reactive with water. Even if you place a small piece of sodium and potassium on the table, you will find that it readily reacts with water vapor present in the atmosphere, leading to an explosion. So, for this reason, potassium and sodium are stored under kerosene in the laboratory, okay, because they react even with the water vapor and an explosion may take place. And as I told you, they burn with a lilac flame and a golden yellow flame, so a fire may fire may take place in the laboratory. Okay, the next one is calcium. Calcium also reacts with cold water, but it is not as vigorous or explosive as the reaction with sodium and potassium. Other elements below this: magnesium, aluminum, zinc, and iron, they don't even react with cold water. They react only with steam to produce the respective oxides and hydrogen. The metals below iron, that is lead, copper, mercury, silver, gold, and platinum, don't even react with steam. So, as we move down the metal activity series, the reaction with water also decreases. Potassium and sodium, they were right on top. They reacted vigorously, and the reaction was explosive with cold water. And they even produced a flame, like potassium produces a lilac flame, sodium produces a golden yellow flame when it burns when it reacts with cold water. Next, calcium. Calcium reacts with cold water, but the reaction is not explosive, neither does it burn. Then next, magnesium, aluminum, zinc, and iron. They do not react with cold water. They only react with steam to produce oxides and hydrogen. They do not burn. And below that, none of the metals react with water. So as we move down the metal activity series, the reactivity of the metals decreases. The next one is reaction with acid. Acid are of two types: dilute acid and concentrated acid. If the acid contains more water and less amount of acid, we call it a dilute acid. And if the acid contains more amount of acid and less water, we call it a concentrated acid. Potassium and sodium react vigorously with dilute acids like dilute sulfuric acid, dilute hydrochloric acid to produce hydrogen. The reaction is very vigorous and sometimes it may be explosive. Calcium also reacts with dilute sulfuric acid, dilute hydrochloric acid to produce hydrogen, but the reaction is not as vigorous as that with potassium and sodium. Magnesium also reacts with dilute acids to produce hydrogen, but the reaction is not vigorous. So, as we move down the metal activity series, the reaction with acids become less vigorous. Aluminium, however, does not react with acids because aluminium readily reacts with oxygen even at normal temperature, which we have already done. A layer of aluminium oxide is formed on the aluminium, which prevents any reaction with acid. Then we have zinc and iron. Zinc and iron, they do react with dilute acids, but the reaction is very slow. So zinc, iron, and lead, they react more with concentrated acids, producing hydrogen. Lead does not even react with dilute hydrochloric acid. Zinc and iron do react with dilute acids, but the reaction is very slow. lead does not even react with dilute acids. So zinc, zinc, iron and lead react with concentrated acids to produce hydrogen. Then all the metals below hydrogen in the metal activity series do not react even with concentrated acid. So only the metals which is above hydrogen in the metal activity series will react with acids, whereas the ones below hydrogen in the metal activity series do not react with any type of acids. So from the metal activity series, we come to know that as we move down the metal activity series, the reactivity of the metals decreases. Potassium is the most highly reactive metal and platinum is the least reactive metal. Metals above hydrogen in the metal activity series can displace hydrogen both from water and acids, whereas metals below hydrogen in the metal activity series cannot displace hydrogen from the metal activity series. Now, it has also been observed that a more reactive metal can replace a less reactive metal from its salt. So, a more reactive metal can displace a less reactive metal from its salt. Let's see this example. Copper plus silver nitrate gives copper nitrate plus silver. Copper is above silver in the metal activity series, hence it can replace or displace silver from its salt. Similarly, the other one, zinc plus lead nitrate gives zinc nitrate and lead. Zinc is above lead in the metal activity series, so it can displace lead from its salt. Okay, only those metals which are above the other metal from the metal activity series can displace them. A lower metal can never displace a higher metal from its salt. Thank you, everyone. I hope you all understood the metal activity series and the various information it gives us. Thank you so much, everyone.